Okay, we're using this to catch up with our first set of notes on Unit 1. Unit 1 is on linear equations. The sets of notes that we have will go on the next page. First, the phrases for translating verbal and algebraic expressions, and then the actual notes of simplifying polynomial expressions. So the phrases page should already be pre-cut for you. These are just to go through and identify using these words to identify different operations in word problems. So these are just a couple of notes. You're welcome to come back to this at any point in time. We have addition, subtraction, multiplication, division, equals, and parentheses. For the actual note portion today, we're looking at two parts of simplifying polynomial expressions. We're looking at the distributive property and the combining like terms. With the distributive property, we have these three problems. We have 5 parentheses 2x plus 7. Now this is a review from when you were in over the last couple of years. Let me show you. I'm trying to make this bigger. There we go. So remember the distributive property, how we operate the distributive property is we distribute using multiplication the constant out front to the terms inside the variable, inside the expression and inside the parentheses. So we use multiplication. 5 times 2x. 5 times 2 is 10. The x just comes along with. And the 5 times 7, that's 35. Looking at our second expression, we have s squared. This is not a 5, that's the letter s. Minus 2 inside the parenthesis. And we have negative 3 outside the parenthesis. So we distribute the negative 3 to every term inside the parenthesis. Negative 3 times s squared. Negative 3 times negative 2 is positive 6. In problem number 3, we notice that we have 3 terms, but with these 3 terms, the only thing that's out front is a negative symbol. So we distribute that negative to each one. That's like multiplying by negative 1. So the values, the actual numbers won't change. What does change is if they're positive or negative. A negative times a positive is going to be a negative. So negative 3c squared. A negative times a negative is a positive. So that becomes positive 4c. And a negative times a positive 1 is going to be a negative 1. And what you notice about each one of these terms is nothing can combine together. They're all separate terms because the variable creates the term a little bit different, so therefore we cannot combine these. However, in the second half of these notes, we have combining like terms. So like terms happen when the variables are the same. They're the same letter, and they're the same exponent. So that's b cubed. In that example, here, it's d squared, d squared, d squared. So if we look also over here, these are examples of non-like terms. So 2 and 2x, we cannot combine those. Negative b and negative 5b squared. We can't combine those because this one's squared and this one's just b. So in problem number 4, when we combine like terms, we have 3c squared minus 4c squared. If I have 3 of something and I take 4 away, that leaves me in the negative 1 c squared. Or you could look at this as just negative c squared. That 1 doesn't have to be there. In problem number 5, we have 5y. The only other term that can combine with this 5y is this positive 4y. If I have 5y's and I add 4y's to it, I now have 9y. I then have this negative 2x. I can't combine anything with the negative 2x, so I'm going to bring it down. And then I have this negative 4, which I'm also going to bring down. There's nothing that can combine with anymore. I cannot simplify this expression anymore. In problem number 6, we have 3x. Here we have 2xy, so that cannot combine because this has a y. We have 6z. That cannot combine because it's z, not x. And we have negative 6xy. So we cannot combine this 3x with any of the terms here because there's nothing that just has an x. So 3x is going to come down all by itself, and it's done. Here I have 2xy. And over here I have negative 6xy. So what I can do is I can take this 2xy and subtract 6xy from it. 2 minus 6 is negative 4. And then the xy joins along. What's left is 6z. Nothing can combine with the term 6z, so I'm just going to bring it down. In our practice problems, I'll go ahead and do a couple for you. In our practice problems, if we look at problem number 9, in problem number 9, we have 2x squared minus 1/2 parenthesis 12x plus 6. It's important to note that we deal with this parenthesis first. The whole adding and subtracting and combining like terms, that will happen after. So here I have 2x squared. I'm just going to bring it down. The easiest way to deal with the fraction is just to talk yourself through it. Negative 1/2 12x. What is half of 12? That's 6. The x comes along with half of 12x is 6x. And then to put it all together, negative 1/2 times 12, positive 12x is going to give me a negative. Talk your way through it. Here I have negative 1/2 times 6. Half of 6 is 3. Negative half, positive 6, that gives me a negative. Just talk yourself through it. In problems 10 and 11, we have several terms and multiple parentheses, and we want to deal with the parentheses first. At the beginning part of problem number 10, I have this set of parentheses, but I have no value out in front. So if I have no value out in front, there's nothing to distribute. So therefore, the parentheses just go away. I have 4k squared plus 8km plus 2. In the next part of the problem, I have negative. I'm subtracting by this, what's in the parenthesis here. I have to distribute this negative to each one of the values. 2km becomes negative 2km. 3m becomes negative 3m. Now I want to combine like terms. I have 4k squared over here. I have nothing like k squared, so I'm just going to write 4k squared. It's done. Here I have 8km, and here I have negative 2km. If I have 8 of something and I take 2 away, I'm left with 6. And in this place, in this problem, it's km that I'm left with. The last part of this problem, I have nothing that combines with 3m, so it's going to come down. And I have nothing that combines with 2, so it's going to come down. Side note here, the reason why I started with 3m instead of 2 is because in math, we always deal with the variables first, and we always write out the variables first. Preferably, the one with the highest exponent normally comes first. And the constant often comes at the end. In problem number 11, it's a similar setup. There's a bit more sitting outside the parenthesis to start the problem. This 2x squared, there's nothing that it's multiplying or anything, so I'm just going to bring it down because I want to get rid of the parentheses first. In this part, I have nothing out in front of this parenthesis, so there's nothing to distribute, so there's no changes. So I just remove the parenthesis because there's nothing sitting out front to distribute. I've gone through, I've eliminated these parts and brought them down appropriately. I have plus 6. There's no multiplication here yet, so plus 6 is done. What's left is negative or subtract 2x plus 3. I have to distribute this negative to both of them. 2x, positive 2x becomes negative 2x, and positive 3 becomes negative 3. Now I combine like terms. I have 2x squared here. I have negative 5x squared here. If I start with 2 and I subtract 5, I end up with negative 3x squares. And I like to cross them off as I go, so in that way I don't bring them back and accidentally add them in later. I have 3x next. It can combine with this negative 2x. 3x minus 2x is 1x. Those go away. What's left is 6 minus 3, and 6 minus 3 is 3. They're done. There's no additional terms here for me to deal with. There's nothing I can combine at this point. This is just an expression, so there is no equals, there's no solving at this point. Problem number 12 is looking at this as a word problem. It says a rectangle has a length of 5x minus 2 and a width of x. Write an expression that represents the perimeter in terms of x. Well, if it's an expression, that means there's no equal sign. I already know that. And I'm starting with the idea that it's a rectangle and I have to find the perimeter. So the first thing I'm going to do is draw a rectangle. I'm told that this rectangle has a length of 5x minus 2. So this is going to be my 5x minus 2. And one rule I know about rectangles is what's the length on one side is the exact same length on the other side. So 5x minus 2. And I also know that the width is x. So if this width is x, this width is x. The final part of this puzzle is that I have to find the perimeter in these terms. Well, perimeter is just adding up all the sides. So one way I can do this is I'm just going to write out all the sides and add them together. I have 5x minus 2 plus x plus 5x minus 2 plus x. There's no multiplication. I know that there's other formulas for perimeter, but in this case, I just put them all out here and just added them up. There's no multiplication at all. All I'm now doing is combining like terms. I have 5x here. I have an x here, an x, 5 more x's, and an x here. 5 plus 5 is 10, 11, 12. 12 x's, and each one of them goes away. Negative 2 minus 2 is negative 4. There's my expression for my perimeter. So if I ever found out what x was, what that value was, like if it was 1 or something like that, I'd be able to find my total perimeter. That concludes our notes for simplifying polynomial expressions. If you have additional questions, you know that I'm available in the mornings to help out. Thank you so much.